Something just moved beneath Triton's ice. At least, that's what a team of planetary scientists whispered when the latest data packet from an orbiter simulation hit their screens. What they saw wasn't a glitch, wasn't a cosmic ray strike, and wasn't some random noise in a sensor that no longer works. It was a shape, a displacement, a ripple spreading beneath the frozen surface of Neptune's largest moon, in a place where nothing should be able to move at all. If this is your first time hearing about Triton, buckle up, because this place is not just another icy moon drifting in the outer darkness. Triton is a world so bizarre, so physically impossible, that some scientists quietly admit it might be the strangest object in the entire solar system. It orbits backwards. It likely came from the Kuiper Belt. It's colder than anything you've ever imagined, yet somehow it's erupting with towering geysers that blast nitrogen gas 8 kilometers high. And now, according to new high-resolution thermal models and gravitational anomaly maps, something under that ice sheet shifted. What kind of force can move anything beneath the crust colder than liquid nitrogen? What kind of environment could allow motion when temperatures plunge to minus 235 degrees Celsius? And what if what moved wasn't geological? Before we get to the part that will absolutely melt your brain, you need to understand Triton's biggest secret. Beneath that impossible frozen surface, scientists believe there may be a hidden global ocean, one warmed not by sunlight, but by tidal flexing and radioactive decay deep inside the moon. Imagine that for a moment. A vast, pitch-black ocean locked under 100 kilometers of solid ice. It would be one of the most isolated environments in the universe. And yet, where there's water, there's always the possibility of life. Not complex organisms, not glowing aliens or giant creatures. No, far simpler, far stranger life forms that could thrive in total darkness, feeding on chemical energy, just like the creatures found around deep-sea vents on Earth. So when that anomaly appeared, that shifting thermal spot rising just a little higher than the models predicted, the reaction wasn't excitement. It was silence. The kind of silence where everyone in the room knows they've just seen something they weren't prepared to explain. Was it a rising plume? A moving pocket of meltwater? Or was it something alive? The moment scientists saw the pattern, one comparison kept coming back again and again. The thermal profiles looked eerily similar to the heat signatures generated by swarms of microorganisms migrating around hydrothermal vents on Earth's ocean floor. But before you jump to conclusions, let's break this down. Triton's subsurface ocean, if it exists, would be buried beneath ice thicker than the height of Mount Everest. The pressure there would be immense. Any life would have to be built around chemistry, not sunlight. And what makes Triton so compelling and terrifying is that some of the chemical ingredients for life not only exist there, but appear to be active. Voyager 2 detected nitrogen geysers. More recently, telescopes measured changes in Triton's atmosphere that don't quite match seasonal models. Something is replenishing it. Something is interacting with the surface. Something is disturbing the frozen plains from below. Now imagine this. Beneath that ice, convection currents push warmer, briny water upward, crack the crust, open narrow channels, and vent material into space. If microbial colonies existed near those warm sources, they could theoretically cluster, divide, move, and spread. That's when the anomaly makes sense and becomes terrifying. Because the signal wasn't static, it moved horizontally. It shifted position. Not quickly, not dramatically, but enough to imply active redistribution of heat. And active heat redistribution in a place with no tectonics, no volcanic hotspots near the surface, and no sunlight can only mean one thing: a heat source that adjusts itself, something that reacts to its environment, something that consumes and produces energy, something alive. Even more disturbing, the movement was located near a region where geysers were once observed erupting in near real time.
The theory forming now is bold. Rising plumes could be carrying not just nitrogen gas, but potentially organic particles, microscopic remnants of whatever lives below. But here's the twist. If something is alive in Triton's ocean, it has evolved in conditions that make Earth look like a paradise. Pitch black, high pressure, freezing, toxic, and ancient. Life in a place like that wouldn't resemble anything we've ever imagined. Forget Earth-like microbes. Think chemistry-driven colonies that behave more like living geological formations. Imagine organisms that grow like crystals, spread like frost, and generate heat in patterns that mimic the anomaly we detected.
But to truly understand what might be moving beneath Triton's ice, we need to talk about one of the strangest theories in planetary science, cryovolcanic intelligence. No, not intelligent beings, not alien civilizations, something far more fundamental. Life forms so primitive, they don't even exist as single organisms, but as networks. Think of slime molds on Earth. They have no brain, no nervous system, and yet they solve complex mazes, optimize routes, and adapt to changing conditions. Now add pressure, chemical gradients, and hydrothermal circulation in Triton's hidden ocean. Suddenly, you have the perfect environment for a vast network of microscopic chemical nodes capable of collective behavior. That's the hypothesis some scientists are terrified to publish, that the shifting thermal anomaly may be the signature of a colony, not an individual organism, a colony migrating toward a chemical hotspot, a colony responding to new heat sources as the moon shifts in its orbit, a colony large enough to create a thermal signal detectable from space. And here's the part that makes this even more mysterious: Triton's retrograde orbit. Because Triton was likely captured from the Kuiper Belt, its internal structure may still be adjusting from that ancient gravitational catastrophe. The tidal heating that results, uneven, chaotic, unpredictable, could stimulate biological migration patterns beneath the ice. In other words, Triton might not only host life, it might be actively shaping it. Now imagine scientists watching this simulation play out. Imagine seeing the anomaly start to stretch as if following a line of stress beneath the crust. Imagine realizing that the motion aligns with a subsurface fracture predicted by geophysical models. If the colony hypothesis is true, that means Triton's ocean life may be migrating along cracks, using them like highways. And what happens if those organisms reach a point where a geyser is about to erupt? What happens if they're periodically blasted into space? That could explain why some spectroscopic observations hint at organic compounds in Triton's extremely thin atmosphere, compounds that shouldn't be there unless something replenishes them. But even more shocking is what this suggests about the origins of life in our solar system. What if life didn't begin on Earth? What if it began in oceans like Triton's, and Earth's early oceans were simply one more stop in a cosmic chain of watery worlds?
So what exactly moved beneath Triton's ice? Let's put together everything we know. We have a thermal signature rising and sliding across the subsurface like a slow ripple. We have chemical hints of active processes replenishing the moon's atmosphere. We have geysers erupting from cracks that align with predicted internal stress patterns. And we have an ocean that should not exist in such a frozen, distant world, yet almost certainly does. The simplest explanation is geological: shifting melt pockets, convection currents, or tidal heating causing redistribution of warm brine. But the simplest explanation doesn't fit the data. The motion was too coherent, too directional, too sustained. That leaves the possibility nobody wants to say out loud, yet everyone is secretly thinking about: the possibility that Triton's ocean contains biological networks capable of collective movement. Not intelligent life, not aliens building structures, but something alive enough to react, adapt, and migrate under impossible conditions. something that could teach us what life looks like when it evolves without sunlight, without continents, without atmosphere, without the ingredients we consider normal. And here's the final twist. This might be the best chance humanity has ever had to detect extraterrestrial life within our own solar system. Mars may be dry, Europa may be deep, Enceladus may be small. But Triton? Triton is active. Triton is erupting. Triton is communicating through geysers that launch material into space, material that future missions could fly through and analyze directly. Imagine a probe entering Neptune's orbit and sampling an erupting plume. Imagine discovering organic chains, cell-like structures, or metabolic byproducts frozen into nitrogen ice. Imagine humanity's first confirmed detection of alien biology coming from a moon orbiting a world 4.5 billion kilometers away. And imagine what it means if the movement we detected wasn't random. If it was the first recorded behavior of an ecosystem older than Earth itself. So the real question isn't, did something move beneath Triton's ice? The real question is, what happens when we finally look closer? What happens when we drill through the ice or fly through a plume and come face to face with the most ancient life in the solar system? Humanity is not ready for that answer, but Triton might give it to us anyway.